Hey everybody, it's Mr. Morris. Let's talk a little bit about scientific notation. What we want to do today is find a way to write really big and really small numbers, and all the numbers in between, in a way that makes it easier to read. Our essential questions are: how can we write large and small numbers in an easy to read format? And what are the steps to convert a number into and out of scientific notation? So it's 384,400 kilometers from the Earth to the Moon on average. That's a pretty big number. So how do we write that so it takes up less space on the page? Well, here we have 5 rules for scientific notation. You'll probably want to pause as we go so you can get these recorded down in your Cornell notes, and I'll read through them as we go. So number 1, the final number must contain digits between 1 and 9.99. Can't be any bigger than that. We have to be less than 10 and bigger than 1. Step number 2, we're going to multiply the final number that we get by 10 up to the power. And number 3, then, that power of 10 is the number of decimal places you move the decimal point to create that final number, again, between 1 and a little less than 10, somewhere smaller than 10, like 9.999. Number 4, if you move the decimal point to the right, the power of 10 is going to be negative, which means the original number was smaller than the number 1. If you moved the decimal point to the left, the power of 10 will be positive because the original number was bigger than 9.9. So let's use those rules to take this number, the distance from the Earth to the Moon on average, 384,400 kilometers, and write that number in scientific notation. So the first thing I'm going to do is go ahead and write my number. So we have 384,400. And even though there's no decimal point in that number, we all know by now the decimal point is right there at the end of the number. So I need to move that decimal point to the left. I'm going to keep moving until I create a number that has digits between 1 and 9.99. So I'll move one place and ask myself, is that number, does it fall between 1 and a little less than 10? And the answer is no. So I continue to move. I might stop here and check again and say, okay, right now if I had the decimal point, I'd be at 38.44. Again, a little bit too big. So let's go one more spot to the left. If I put my decimal point here, we'd have 3.844, which definitely falls in that range between 1 and 9.99. So I can go ahead and draw my decimal point if I want, and then rewrite this in scientific notation. So here we would have 3.844. We'll leave the zeros off for now. So then we go times 10 to the, and again the power will be positive, because we moved the decimal to the left, and we'll count how many places we went. So we went 1, 2, 3, 4, 5 places. So that becomes my power of 10. And now in scientific notation, the distance from the Earth to the Moon on average is 3.844 times 10 to the 5th kilometers. So let's try another one. Let's do the distance from the Earth to the Sun, which is a little bit bigger number. 149.6 million kilometers. So once again, I will write that number. And just like last time, put the decimal point because we know where it is. So again, I got to move the decimal point to the left, so I know I'll have a positive power of 10. It's a really big number. And again, I just keep moving the decimal point and asking myself each time, does this number fall between 1 and 9.99? Maybe I would stop here and say, does this work? But no, it's 149.6, not small enough yet. So I keep going. Nope, 14.9, almost there. One more, and all of a sudden 1.496 definitely falls in that range for step number 1, between 1 and 9.99. So now I know where I need to be. So I can draw my decimal point in, and now count how many places I moved. So I went 1, 2, 3, 4, 5, 6, 7, 8 places to the left. So that means when I write this number in scientific notation, I get 1.496, and again we'll leave the zeros off, times 10 to the, it'll be a positive number, so I move to the left, and we moved 8 places, so we get times 10 to the 8th power. Let's try another one, this time going from a really, really small number, but still the same idea. Okay, the mass of an ant on average is about 0.000003 kilograms. Pretty small, kind of tough to read, so let's make it a little more manageable on the screen by putting it in scientific notation. So again, I will start by writing my number, So here we have 0.0000003. So again, that's way too small. So this time I'm going to move my decimal point to the right. I'm going to move one place and check. So hey, does that number fall between 1 and 9.99? The answer is no, it's still way too small. So I continue to move. Maybe I stop here and check again and say, okay, if I put the decimal point there, we'd be at 0.3. And unfortunately, that's still a little too small. It doesn't fall within that range. But if we go one more time, we would have 3.0, which falls between 1 and 9.99. So I can go ahead and add my decimal point, count the number of places I moved. I went 1, 2, 3, 4, 5, 6 places. And because I went to the right and it was a really small number, we're going to have a negative power of 10. So if I was going to write this in scientific notation, I would get 3.0 times 10 to the negative, because I went to the time 1, 2, 3, 4, 5, 6 places. Negative 6th power. And since we're talking about an ant, mass is in kilograms. Now we can also go the other way. Maybe we have a number in scientific notation and we want to know what it looks like written all the way out in the long form of the number. So again, positive exponents will be really, really big numbers. Negative exponents will be really, really small numbers. So in this case, the average distance from the Earth to Mars is about 2.25 times 10 to the 8th kilometers. A lot easier to read that in a sentence than having to count all those zeros, but maybe we would want to write it out. So this time what I'm going to do is take the number that we start with, so 2.25, and now that exponent, the positive says it has to be a really big number, so I'm going to move the decimal to the right to make a really, really big number, bigger than 1, bigger than 10. Now I'm going to move the decimal point 8 places because that's what that exponent tells me. So I'll go 1, 2, and now I'm running out of digits, so I'm just going to put zeros in as placeholders. So we'll go 3, 4, 5, 6, 7, 8. Move the decimal point and fill in all of those extra places with zeros. And so now, writing this out in the long form, we have 2, 2, 5, 0, 0, 0, 0, 0, 0, and we can even put a decimal if we want. We don't really need to. And again, this is a distance in kilometers. You notice it takes up a lot more space with all those zeros. Sometimes we might need that, but that's why we use scientific notation, to take up less space, make it a little easier to read. And again, we can do one more. On average, a human hair is 6.0 times 10 to the negative 7th meters in diameter. So again, negative means a really, really small number, smaller than 1. And again, a human hair, if you think about it, is pretty small in diameter. So again, I'm going to do the same thing. This time I'm going to move to make a really small number. And I'll move my decimal point 7 places because that's what my exponent is. So here I have 6.0, and so I'll go 1 place, 2 places, and just like last time, I'll plug in zeros as placeholders. 3, 4, 5, 6, 7, and I get my decimal point. And so if I was going to write this out in long form, now that I move my decimal point, we usually put a 0 first. Then we had 1, 2, 3, 6 zeros. And finally our number in meters. We'll do some more practice with this, but this is some basics to tell you why numbers are in scientific notation and how we put them in scientific notation, or if they are in scientific notation, what does that mean? Is it really big? Is it really small? Is it somewhere in the middle? Less than 1, greater than 10? Again, we want to make something that's a little more manageable to write and type and put on a piece of paper.